So okay, so yeah, so this is important. This is important information right here that we just talked about at the end of Friday. Okay, that growth and decay stuff right there. That's important stuff. Okay, so you need to make sure you are good with that for your assessment because that'll come into play. Okay, at some point in time. So let's go to part three. Now, on part three, we have some graphs to make. Okay, and I'm going to suggest that each group create one graph here. Okay, so we'll have red do one, blue do one, green do one. Okay, yellow do a graph. Now, how are we gonna do this? We're gonna make this very simple. Okay, we're just gonna do a T-chart. You guys remember doing a T-chart when you do graphs before? So when you do a T-chart, you select values for X, you plug in the value for X, you generate a value for Y, you create an ordered pair, and it goes in your graph. Okay? So we're going to do something similar with this on these. But I need you to stress that it does make a difference what order pairs, what values for X you select. Because some of these are going to be a lot nicer to work with than others. Okay? I'll also tell you that your grids on these, they're from -4 to +4 on the x-axis and from -12 to +12 on the y-axis, I think. Okay? So I wouldn't pick anything less. I wouldn't pick anything less than -4 or anything greater than +4 for these. Okay, those values are going to get really large or small anyway, and so this kind of helps us control it a little bit and know that we are in pretty good shape. Okay, um, I'll tell you what. When I get kind of started with one here, so you kind of get the idea of how it goes. All you have to do is follow order of operations here. All right. So, for example, a good value to pick for all of these would be what value for x? 1 would be a good one to pick. Also, 0. Because what is any base to the 0 power? No, remember your power exponent rules. 1, right? Yeah. So if we look at A real quick, I just do like x equals 0. I'm just going to put it in here real quick. So it becomes 3 times 2 to the 0 power. 2 to the 0 power is 1. So this becomes 3 times 1, and that becomes 3, correct? So the ordered pair would be 0, 3. Because x was 0. Are we on the same page? Okay, so we're not going to do this anyway fancy. There's not really any good way to do it right now fancy until you learn some more about the patterns of these, which you'll accomplish in Algebra 2 and Pre-Calc. Okay, because you have to really study these in depth to kind of understand how they behave. Okay, so we're just going to pick values for x and plot points. Now, I do suggest at least picking one negative value or one positive value as your function makes sense to do. Okay, you need to have at least one of each kind of value on as you select. That way you have some behavior for some negative numbers for x, and you have some behavior for some positive values for x. Okay, but I want you guys to try to figure out some of these, and I will come around and see how you guys are doing here in just a couple minutes too. But we're going to take a few minutes here and get some graphs up here, and we'll go from there. All right, I'm going to roll the dice, and then that person that group gets to decide what graph they want. So this time you want the number to be rolled, right? All right, so I'm going to roll, and I got. Well, that's the one time I don't need odd doubles. Okay, that works. I got RJ. RJ, what graph would you like to do for the red group? A, B, C, or D? Okay, so you guys mark A. Okay. All right, roll again here for somebody. Okay, Wyatt. What would you guys like for the other group?
B.
B. Okay. And let's see who we have now. Brandon. C or D? C. Okay, so blue group, you have D. Okay. Get busy, start graphing. You guys are free to collaborate, okay? So if you need help with getting checks for your values and stuff like that, that's perfectly fine, okay? We'll try to get 4 values for each one, okay, 4 ordered pairs. All right? Mm-hmm. I mean, all you're doing is plugging in values for x and simplifying. Okay, would you like to see me do another one? That help? I'm also giving you a bunch of clues up here for paying attention. Okay. How about I do one over here on C for a minute? Will that work? So if I plug in -2, I'll do the hard one. Okay. Or the harder, maybe perhaps one. If I plug in -2 for x, okay, then here's my equation. I'll do the work down here so everybody can see it. Okay. I get 3 times 1/2 the -2. Okay. That'll pop up here in a second. There it is. All right. Now, if you guys thought you could get away with just having to know your exponent rules for just that last assessment, you thought wrong. Because look what I have right here. I have a base raised to an exponent, right? I have to distribute that exponent to each part of my fraction. We talked about that. That's one of our properties. So in order to figure this out, I got to simplify the parentheses first. I got to distribute. Okay? So it becomes 3 to the 1 to the -2 over 2 to the -2. Does that make sense? Okay? And then what do you do with negative exponents? You swap their places, right? So this goes on top. This goes on bottom. So I have 3 to the 2 squared over 1 squared. Well, what's 2 squared? 4. What's 1 squared? What's 3 times 4? 12. So here's the deal. 3 to the 1/2 to the -2 becomes 12. Okay? So this order pairs -2, 12. Right down here. All right? So yeah, you have to follow your order. You have to remember your exponent rules on these a little bit, okay? But here again, you can do it this way. You can do -1 also. It follows the same pattern, okay? You take that value, you flip it after you distribute, generate your order pair, okay? So I've done now one for each kind of graph. One where the value b is an integer, and one where it's a fraction. All right. I'm going to put my 0 one in here too, so we have this one depend on a. So 3 times 2 to the 0 is 3. It goes right there. Okay. All right. And talk together. Talk and figure this out together. You don't have to do it individually. Okay. I want to hear some good conversation. All right. So I'm gonna go ahead and start filling these out too, and we'll meet up and see how we are in about 2 minutes time. All right. So talk, collaborate. Make sure you guys are okay with it. You have at least how many points? At least 4. Okay. One of them must be negative. One of them must be positive. All right, A and B, take a look. Okay, if you were assigned A or B, check it out. See if you agree with me. How's it looking, guys? You guys are awful quiet today. Okay. Mason, give me a value. Which graph did he have? C. Okay, let's go to C right now. Okay. Pick a value for x. All you're doing is you select the value for x as x is independent. You plug it into your function, you get a value to come out. Okay. It's just like for a second, Mason, look at the screen. If I have, for example, y equals 2x plus 5, and I'm graphing this just plugging values in for x, right? Well, if I let x equal 2, then y equals 2 times 2 plus 5. What's 2 times 2? What's 4 plus 5? So the order pair would be 2, 9. I picked 2. I got 9 to come out when I picked 2. Okay? Same idea here, only you have x as an exponent this time. It's the same idea. All right? You pick one. I'll work it with you. You pick one. -1, 0, or 1. 1. Okay? So this becomes then 3. Oops. 3 to the 1/2 to the first power. What's 1/2 to the first power? What's 3 times 1/2? 1.5 or 3/2. There's your value. So the order pair is 1, 3/2 or 1, 1.5. Okay? Now can you do 0? What's that going to be? That's correct. Good. Can you do -1? Think about a pattern here. You guys should see now some patterns happening. Okay? Look at your work here for C, Mason. What happened when I did 1/2 to the -2? Can you adapt that work? Okay, that's all you're doing here, okay? Sorry, guys. On C, I pressed the point in the wrong spot, didn't I? Should be up here, -212. Okay, so -1, 6. 1, 2, 3, 4, 5, 6. 0, 3. 1, 3/2. How's it looking, guys? Check yours with mine. Okay, again, all you're doing is plugging in and doing that. And you can use your calculator to do this math too. You don't have to do it all out, right? You need to see order pairs, okay? A T-table would be very highly recommended on these, all right? You have to work on these so I know how you get your order pairs, all right? So however you want to do that, This go around is fine, but I don't have like a T-table set up for you on your assessment. You have two of these graphs to do. You have to graph them by hand. You use a graph calculator. Okay? How many points required? 4. Each one's a half point each. All right? So if you pick an X value and you have the correct corresponding Y value, you get a half point for that. Okay? If it's plotted on the plane correctly, you get your half point. Okay? You guys all have the same thing for your graph? So what's happening here? What happens if I make a value negative? What happens in that case? Okay? If you gotta use this graph A as kind of a base for everything else, what happened when A was negative? Right here. What happened to it? Okay? What happened? It goes down instead of going up, right? Are you guys okay today?
No.
You guys are awful. You're very tired. I usually have no problem getting you guys a little motivated here. But I feel like today I'm kind of having to push a little.
Yeah, if you weren't confused, you would be very
Yeah.
motivated.
Well, they're here. They're just invisible.
Okay.
Okay.
What do they taste like?
The project's invisible too. All right. So, okay, when you use the negative sign for your A value, what it does is it inverts your graph. So instead of it going upward like normal, it actually goes on the opposite side of the x-axis. It's called. Have you guys heard of a reflection before?
Yeah.
So basically, a negative sign calls a reflection on the x-axis. See how that happened? If I put this one on the same graph, it's going to go down like this. It's going to be a mere reflection of the original. Okay? Did the same thing happen between C and D? It should have. Okay? It should have. What I should have done was have somebody in each group do each one so that you guys all can compare notes and get them all together. I'll send this out for you guys so you have all 4 graphs, okay? So if you don't have them all right now, that's okay, but you'll get them all. I'll send this template out to you. You can update your template. Are we good? Okay, so we talked about number 2, right? Okay, and again, how does the graph change when B is greater than 1 versus when B is between 0 and 1? Okay, when B is greater than 1, what does our exponential function model? Growth or decay? B is greater than 1. That model's growth, right? You guys decided that you guys came up with these restrictions on your own on Friday. Remember that? Or did that just seem like a long time ago? You don't remember Friday? All right. So then the LMS model decay, right? Remember, if B is an integer greater than 1, it's growth. If B is a proper fraction between 0 and 1, it's decay. So that's what these graphs look like, right? Look at A and C. Okay. Doesn't A show growth? B was 2 on that one, right? B was 2. Okay. Did that show growth? The numbers are getting larger as you go to the right, correct? And on C, does not show decay? The numbers are getting smaller as you go to the right. There's your difference maker. Okay. All right. We need to get to a problem like number 4. All right. We're going to do this together real fast. We're going to make these tables real fast. Okay. Are we on problem 4? We need to see what happens on these. All right. So let's just do some quick math here. All right. We're doing 2x for function f and 2 to the x for function g. And I just need to get some values in these tables. Okay. We might not even fill them in all the way. All right. Let's just see what happens. So let's start with 0. Okay. So for f, what is 2 times 0? 0. What's 2 times 1? Keep going. 2, 3. How about a little excitement? 4. Give me something here. 5. Go backwards. -1. And -2. Now let's do 2 to the x power. Okay. Well, again, we'll start with 0. What's 2 to the 0 power again? 1. 2 to the first power. 2 squared. 2 cubed. 8. 2 to the fourth. Okay, we'll stop there. Go backwards. What's 2 to the -1 power then? 1/2. Yes. Okay. Very good. Remember, a negative exponent doesn't mean it's a negative value. It means you have inverted your fraction. Okay, you flipped it. It's reciprocal. Okay. All right. What's -2 then? 1/4. Very good. All right, let's get some of these plotted. You guys can do some of this, okay? Get some of these points plotted on here with me. Let's see what we got here. So I'm going to graph, you know what? I'm going to graph F in blue and G in red, okay? And I'm just going from -2 to +3 for right now, okay? How's it looking, guys? How's it looking? You guys got these plotted already for me? All right. We're going to use this to do some analysis, okay? Because on your assessment, you're going to get problems that compare a linear relationship with an exponential relationship. You have to answer some questions based upon what you see on your data, okay? So let's try that. Let's do that. We got the graphs? Okay, so question. Which function has greater value over the interval -2 to 0? Okay, so figure that out. And then we're going to do the same thing from 1 to 2. Okay, figure that out. And I think we're going to do the same thing from x is greater than 2. All right, so we're going to chunk this off, okay? I'll have you guys break up maybe 2 groups, and I'll talk about the middle group, okay? So let's do yellows. Let's do blue and green this time. Have this half of the room talk. You guys are going to do problem 6, okay? So we're talking about the section from -2 to 0, right here. Okay, you guys have this section right here, okay? So this is blue and green, okay? And then red and yellow, you guys are going to take after 2. So you guys are going to take from there, okay? And from there. And I'll take the piece that's in between. Fair enough? All right, discuss, okay? So blue and green, you have problem 6. Red and yellow, you have problem 8. And I'll help you out with problem 7. How's that sound? Okay? Discuss, okay? Discuss your question and prepare to explain your answer. Go. I want to hear some good discussion. I've been waiting for this all day. Go. Shoot. Go. Come on. Come on. Talk. What's your graph showing you in your table? Okay? Real big key.
Oh. The red is better.
Yeah. I mean, yeah, I guess you're right. Yeah, they were exaggerating. They were number 6.
I think it does the answer question 8. I think that asks you for which function on that interval is greater. It's a greater value. F or okay. So you're not understanding the question? Okay, so the question is asking you on your interval, which function has the bigger output? Is it function F or is it function G? Is it the linear function or the exponential function? Okay, that's what that's asking.
I have no clue.
It does for this side of the graph.
Why is more valuable? No, what? Well, we're looking at y times the nine.
Your question is, which graph has the bigger output? Okay, under the assigned interval.
Y is out.
Y is out. Okay. Which function has the bigger value on your output, on your given interval? Okay.
Right.
So function g is the exponential.
Right.
Why is my
Well, then we need g.
Are you really asking me to be
I
invited?
think it's asking.
Okay, so quick question, guys. Okay, blue and green. What did you say? Show me thumbs up for red, thumbs down for blue. Which one has the bigger value? I would agree. Okay.
Sweet.
Why is that the case? You can make you can explain it. Emily? Right. After zero, blue becomes negative, right? That's always going to be less than what red is, because red's never going to get to zero, correct? We talked about that the other day. Okay. So the exponential graph is going to be good, okay, until x is greater equal to 1. If x equals 1, they have the same common point, right? They're both equal to 2 for their output, correct? Same thing for x equals 2, right? They both have a common output. It's 4. How about what happens after 2? X equals 2. Red and yellow? Which one's greater? Show me a thumb. The exponential graph is thumbs down. F of x is blue, g of x is down. I would agree. The red one, right? So, are we okay with those things? We can see this from our graph, right? But, what about the interval that I said I would do? I kind of fit. I'm not going to do it. I'm going to do it. I'm not going to do it the right way. Okay? Which one's greater? Which one's greater? Between 1 and 2. Which one's greater? Care to venture a guess? Red was greater from before 1. Red was greater after 2. So wait a minute, I want to make sure the colors match up. So this has to be 2 to the x, okay? And the other one is 2x, correct? All right, if I go to my graph, check this out. There they are, right? Okay, so I'm going to really zoom in on that area between 1 and 2. Are you surprised?
Not really.
You said blue.
That's scary.
You said blue all along? Because blue is greater on that interval. You guys see that? Because why is blue greater? Because the rate of change is. Okay. So what's the conclusion here? Can we always assume that an exponential function is greater? No. Okay. We have to analyze. We have to make sure we are analyzing things correctly. Okay. Only then will we know for sure. In fact, here's my table of values here. You can see that on the table too. I'll go between positive 1 and positive 2. Right there. See the top ones right there? Between 2 and 4? Compare red to blue. Less, less, less. Okay? Everybody see that? Yeah. Okay? So, let's get these answers on your notes so we make sure we're good to go. And then we're going to move right along here, okay? And I think we're going to be in pretty good shape. We're going to wrap this up on Thursday. We'll review for your assessment on Thursday, and you take your assessment on Monday. Okay? All right, so blue-green. Okay, which function had greater value? That would be g of x, right? Okay. Well, mine, what was that one? Correct. Okay, and on 8. So do you find this interesting or no? Not really. Is this because you're over it, or you're not with it, or you just all the above? Okay. Will you promise me to get some rest and come in more lively on Thursday? Just a smidge more lively. Okay? Because I do. All right. Hey guys, we're down to our last problem here. Okay? Let's just read it real fast. Okay? So, here's the thing. Just think about this for a second. This is true. Okay? So if f of x equals 50x and g of x equals 2 to the x, okay, will f always be bigger than g? There's going to be a point somewhere, right, where that's not true, right? Because remember, you're going exponentially, right? So somewhere, g is going to overtake x. Now, f's going to start out and be bigger, right? After 0, of course, correct? Yeah, if we just concentrate on that, all right? Okay, but that's, yeah. How about the next one here? Okay, what do you think? We're just going to talk about these. We don't have to graph these. Okay, we're just going to talk about them. Okay, what do you think? Questions? Is Alex? We just said that Alex is wrong, correct? Is Glenda correct? Would you like to see those graphed? I'll put them on my graphing calculator. Huh? That's fine. Okay. So, but I need to know what they are. So you have to tell me what they are. What's the exponential function? Is it 2? We're doing Alex first. Okay. So what's the is that 2 to the x for the exponential though? Okay. All right. So we just got to change this into 50. We'll do it. All right. Now check the graph. I'll get it back out here. They're going to both on here. Oh, I didn't put that one on. I didn't define it. There we go. Okay. So that should be enough to tell you what's going on here, right? Is red always bigger than blue? Is blue always bigger than red? No. Okay. Let's go to the next one. Okay, Emily, you did such a good job. What's Glenda's conjecture? Is it 1.1? 1.1 to the x? What's the linear? So 50? Thoughts? It still changes, doesn't it? It just changes above a lot higher up than it did before, but it still changes, right? So will either of them ever be correct? Is it then? Can you always say that a linear function or exponential function has bigger value? No, you can't. Okay, that's the reason why. All right. Okay. Thanks for bearing with me. All right. Try to get part 3 done. I want to take questions on Thursday over stuff. All right. And go over your review assignment. All right.